Chapter 9, Question 6. In this one, we have a 3-child family, and we want to know the probability of having all 3 children be girls. So we have 3 children, and gender is really the only consideration here. However, we have to think that physically, how many different families really can you get out of this having boys and girls? It turns out that in probability, you have to also count anything that's physically different. And so we have to consider birth order. Was the girl or the boy born first or second? So when we consider this, let's list all the ways we can get 3 families considering birth order and gender. So the first one is we could get what we're looking for, 3 girls. Now there's one way to do that, because if you switch these girls around, even though each individual is different and the order they were born in might make a difference somehow like that, but you couldn't tell the difference by gender. So the oldest is a girl, the middle child's a girl, the youngest is a girl. So there's one way to do that. Let's throw in 1 boy to the mix. So we could have 2 girls, and they could come first and then the boy, or the boy could be born in the middle with a girl on the end, girl, boy, girl, or the boy could be born first, followed by 2 girls. And I think if you try it, those are the only 3 birth orders that you can get, with 2 girls and 1 boy. Let's do 2 boys and 1 girl and kind of do the same thing. We could get the 2 boys first, followed by a girl. We could get a boy, a girl, and a boy. Or the girl could have come first, and then there's 2 boys. And notice that really is the only 3 ways that it can be done. How do we know? We have to look at it. If you try it another way, you'll see you'll get one of these 3. But do try, because that's how you come to understand. And finally, the only other thing we could do, 2 boys and a girl, 2 girls and a boy, 3 girls, is to have all boys. And there's only one way to do that, because if you interchange these B's, it's still the same. 3 boys, oldest boy, middle boy. Okay. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 total ways of having a family of 3 children. And the option we want is the probability that they're all girls. Well, there's one of those options out of 8. Our probability is 1/8. The important part of this problem was learning about the counting that's necessary to come up with this 1/8. This is the answer in the back of the book, but if you want to use the decimal and the percentage, 1 divided by 8, 0.125, move the decimal over 2 places, and you have a 12.5% chance of having a 3-child family with all girls.